Hi everyone, happy Friday! So today we are going to talk about a few of the periodic table groups and some properties and periodic trend. Here's a typical periodic table. As we are going to go through each group and to figure out what kind of specific property they have, why we call them groups. Okay, alkali metals, alkaline earth metals, transition metals, and the metalloids. Those are non-metals. And this group has a specific name. We call them halogens. And this whole group are noble gases. And these groups over here, they give them specific names too. Okay, each group have a special name because they have similar physical and chemical properties. And we learned about valence electrons, right? This whole group has one valence electron. This one is two, and 3, 4, 5, 6, 7, 8. Today we're going to go through each group in the detail. Okay, so before we go through the groups, I want to introduce you another a vocabulary for the electrons. We call the electrons in the most outer energy level valence electrons. And then people give the electrons in the inner energy levels, like the ones, for example, this one has totally 4 energy levels. The first 3, we call them shielding electrons. It works as a shield. It's shielding this valence electron from the nucleus. This is a positive, this is negative. There's an attraction between them. When there's more energy levels, more shielding, the attraction between this valence electron and the nucleus would be smaller and smaller, so it's easier to lose this one. Okay, so that's called shielding electrons. Okay, so now let's have a look of the electron energy levels and the valence electrons. As we learned yesterday, this has one valence electron, group 1, group 2, and 3, 4, 5, 6, 7, 8. This corresponding to the number of valence electrons. This last group has 8 valence electrons. They have 4 valence electrons, so they don't need to lose or gain electrons. Okay, so now let's have a look of for each group, okay, and we give them a family name. We give them a name. People call them family too. They have similar physical and chemical properties. It's all because they have the same number of valence electrons. So because valence electrons affect the reactivity, let's have a look of group 1 first. Okay, group 1 have lithium, sodium, potassium, rubidium, cesium, and francium. Okay, those chemicals are very soft metals. They're metals, but we can cut it by using a knife. Okay, they are very reactive because they only have one valence electron. It's very easy to lose that one. Okay? Lose the electron to become too stable. So they cannot, you cannot keep them in the air because they are going to react with the air immediately. And normally we have some in the lab. They are kept in mineral oils. They react with water very easily. You can watch one video today about alkaline metals reactivity. Okay, they are very reactive, and the reactivity increases from lithium to francium. This one, 87, is hard to, I think it does not exist in the world. It's only exist in a very short time. It reacts dramatically with air and water, so you can't even keep them in oil. So the reason is because if we look at this one, the energy levels are increasing. So the sodium have 3 energy levels and potassium have 4. So it has more and more shielding. So this one valence electron is getting further and further away from the nucleus. So it's getting easier and easier to lose. That's why the reactivity increase from lithium to francium. Okay, so the second group is called alkaline earth metals. They're also metals, they're shining, and they are kind of reactive, but not as reactive as the first group. The reason we call them earth metals is because many of those are found in the rocks, in the earth's crust. Okay, so here's a burning of magnesium. It's a very bright color we can burn. We normally show that in the lab. Okay, now let's look at the middle region. They are transition metals. Transition metals, most of them like copper. Here's copper, zinc, and this one, nickel is the one we make we make zinc is the one we make penny, we cover with copper, and nickel is the one we make nickels. Okay, here's silver, here's gold, and most of them are very good conductors, and they are malleable, means we can make two different we can make it to wires and make it to different shapes. So pennies, this is for the car wheels, airplane, and jewelry. Lots of stuff we can use it to. Okay, and then a typical another group is called halogens group. The halogens group, they include fluorine, chlorine, bromine, and iodine, and they are also reactive because this whole group have 7 valence electrons. They are in group 17, so we call them also representative element group 7. They have 7 valence electrons. They only need one more. So it's very easy to gain one. So that's why they are very reactive. Okay. And compared to this five, fluorine is the most reactive because it has less shielding. It only have one inner layer, and this has two inner layer. Okay, it's less shielding, it's more attraction between the nucleus to the electrons, so it's easier to receive one compare fluorine to chlorine to other stuff. So fluorine is the most reactive. Um, Actually, this is the most reactive nonmetal. Okay. It's very easy to react with the alkaline metals. That's why sodium and the chlorine can form sodium chloride. And also they are poisonous. Chlorine has been used as a chemical weapon during the war. And the last group, they are very typical noble gases. Okay? They have whole valence electron arrangement, and they are like the singles. They are happy by themselves. They don't need to combine with any other stuff to form compounds. So they are gases at room temperature. They are not reactive at all. Okay, that's the end for the video. And please enjoy your weekend and watch the rest of the few videos.